Welcome students. In this lecture, subunit of this topic differentiation is derivatives of inverse functions. And in this subunit, today we are going to solve the exercise number 1.2, and from this exercise we take the question number 2, that is find the derivatives of the inverse function. We simply find out the inverse of the given function, derivatives of the inverse of the function. First example, that is y is equal to x square into e raised to x. In the last question, we have to solve the inverse functions, derivatives of the inverse function. Such like, in this question also, we have to find the derivatives of the given functions by using the inverse. Suppose the derivative of the given function is dy by dx, and inverse of this becomes dx upon dy. By using formula, we solve the last question. But in this question, we find simply the derivative of this y and find the inverse of that function. Then what it becomes? Derivative of this y is dy by dx. Okay. And inverse of this becomes inverse of the derivative of this function, that is derivative of y is dy by dx, and inverse of this function becomes 1 upon dy by dx, and 1 upon dy by dx becomes dx upon dy. We simply using this formula in this question number 2. Okay, we are using, that is derivative of the given function. First we solve the derivative of the given function, and inverse of that derivative of the function becomes 1 upon dy by dx, and 1 upon dy by dx becomes dx upon dy. Therefore, we have to write the dx upon dy is equal to 1 by dy by dx. Finally, we find this in such way. Okay, first example is y is equal to x square into e raised to x. This becomes, first we have to find the derivative of this y with respect to x. It gets, this is like u into v by using the formula u into v. Then this becomes differentiate y with respect to x, because it is given in terms of x. Therefore, dy by dx is equal to d by dx of x square into e raised to x. Then using the uv formula, that is keep the first function x square as it is, take the derivative of the second function, that is e raised to x, plus keep e raised to x as it is and take the derivative of this x square, is equal to, it becomes x square into derivative of e raised to x is e raised to x plus e raised to x as it is, and derivative of x square is 2x. From these two, we can take common from these two terms, that is x into e raised to x. It becomes x remaining into this first term plus 2 remains in the second term. This becomes dy by dx. but we have to find the inverse of this function. Okay, therefore, by using the formula, what is the formula? That is dx upon dy. Dx upon dy is equal to 1 upon dy by dx. Therefore, it becomes is equal to 1 upon. What is dy by dx? Dy by dx becomes x into e raised to x into x plus 2. This is the inverse of the derivative of inverse function. Inverse function is y is equal to x square into e raised to x. This is the given function. We first find out the derivative of that function and gets the inverse of that function, that is dx upon dy. In this way, we solve the another examples. First example is solved here. Second one I will take now, that is y is equal to x into cos of x. In this way, we solve also this second example, that is differentiate y with respect to x with respect to x, we get dy by dx is equal to d by dx of x into cos of x. That is equal to, we use the u into v formula, taking the derivative of the second function. First function keep as it is, take the derivative of cos of x, plus keep cos x as it is and take the derivative of x. That becomes x into minus of sine of x. Derivative of cos of x is minus of sine of x, plus cos of x into 1. This is minus x into sine of x plus cos of x. That this becomes dy by dx. dy by dx is equal to minus x into sine x plus cos of x. But we need to find out the inverse of this function. This becomes, that is dx upon dy is equal to 1 upon dy by dx. This is the inverse of the given function. That becomes 1 upon minus x into sine x plus cos of x. Okay. Now third example. This is the answer. Answer of that second, and y is equal to x into 7 raised to x. This is the third example, and solve it by using the previous method, that is dy by dx, differentiate y with respect to x, we get dy by dx is equal to d by dx of x into 7 raised to x, that is equal to d by dx of 7 raised to x. Keep x as it is and plus 7 raised to x as it is and derivative of x, that is equal to x as it is, derivative of 7 raised to x is 7 raised to x into log of 7 plus 7 raised to x into 1. This is 7 raised to x common from this, 1 plus x into log of 7. This is becomes dy by dx. And next what? dx upon dy. This is the inverse of the given function, that is 1 upon dy upon dx is equal to 1 upon 7 raised to x into 1 plus x into log of 7. 1 plus x into log of 7. In such a way, you solve all the questions. There are remaining 2 questions in this question number 2. Then next, in the next lecture, I will come back with the question number 3. Okay, students. Thank you very much.